All right, so for today, we're going to be learning how to solve equations using the log function. So the log function actually allows us to make difficult looking problems a lot easier, okay? Even the easy problems look kind of tough sometimes. So let me show you what I'm talking about. So we'll start off here. This is going to be example number 1 for you guys. So if I give you a problem that looks like this, let's say it's 2 to the x equals to 14, and I tell you solve for x, okay? What we have been doing before is we would say, okay, in order to solve for x, I got to get the same bases, right? We wanted to get the same base. So just to give you like a quick flashback, 2 to the x equal to 8, we would be able to say, oh, 8 is just 2 to the third, so x equals 3, right? Like we were able to do that before. That's stuff that we've learned. And we said, oh, well, because the bases are the same, the powers are the same. So there you go, x equals 3. But is there a way for me to represent 14 as 2 to some power? No, right? Like there is no way for me to use an integer value for 2 to a certain power to give me a 14. It won't work. Okay? So if I cannot get my 14 with the same base, then there has to be a way for me to do this so that I can kind of do a workaround, right? So here's your workaround. You're going to do log of 2 to the x equal to log of 14. Now you might look at that and say, well, that doesn't make it look easier. It looks more complicated, right? Well, yeah, it looks more complicated, but what can you do to a power when there's a log there? What are you allowed to do based on properties? Anybody remember? So if you have a power of x, but it says log 2 next to there, what can I do with that x? Yeah, I can put it right here. Yeah, x log 2, right? So it's going to be x log of 2 equals log of 14. Now, if I want to get x by itself, what do I do with log of 2? Should I add, subtract, multiply, or divide? Because right now it's x times log of 2. So how do I get rid of the times? The opposite of addition. Of multiplication. Divide, right? Yeah, you want to do the opposite, right? Since I'm doing multiplication, I'm going to divide it. So x is whatever log of 14 divided by log of 2 is. So I'm just going to do that on my calculator. Log of 14 divided by log of 2. My answer comes out to 3.807. And I'm done. That's my solution to this problem. Okay? So in order to solve these problems for today, you're going to notice that you cannot write the same bases for these problems, okay? So, and it doesn't matter what kind of numbers they give you, okay? It can be 3s, 4s, 5s, it can be decimals on the other side. Right now we'll look at your assignment just so you can kind of get an idea of it. But it doesn't really matter what numbers they're using. Just use the log function to get the power down, and then once you do that, just solve for the letter. Okay, so let me show you another one of these. So let's try a I think we can do this. Let's try a 1/2 to the y equal to we'll do a 10. Okay, now again, you're not going to be able to write 10 as a 1/2 to a specific power, right? So what I'm going to do is a workaround. I'm going to say, okay, I need that y to be all by itself. I got to bring it down from from it being a power. So what I'm going to do is I'm going to introduce something to both sides. I'll introduce log. So log of half to the y equals log of 10. Okay? Now, because of the properties of logs, I am able to get this y power in front of the log. So I'm going to write y, not equals, sorry, y times log of half is equal to log of 10. By the way, there is a property that tells us that log of 10 is equal to 1, but if you don't know that, don't worry about it. Yeah, your calculator will. So what do I have to do to both sides to get y by itself? Just divide, right? Let's divide this out. Log of half. We're going to divide on both sides. So y is equal to, now you just go to your calculator, right? Log of 10, so log of 10 divided by log of half. So it's negative 3.322. Now, normally I'd ask you guys to do one on your own. The only problem is I don't know if you have a calculator with you right now, so I'm not going to do that. Okay? If you do have one, great. You can try it. As I'm going through this, you can be doing it on your own. But once I get the homework assigned, I'm going to bring out the calculators just in case you guys need them. But they're not too hard to do. I'm just going to do one more of these, and I'm going to show you what section 7.9 is like. Okay? So let's just do one more of these things. And then we'll move on. So number 3, and then we'll do the what they would call the advanced ones. Okay. Now you might see something that looks like this. So these are not considered the advanced ones. The reason why they're not considered advanced is because the power is still just a single x. The advanced ones will have like a power of 2x or a power of x minus 3, right? Like the power has expressions in it. So those are called more advanced. So we'll do some of those right now. But let's do this one before we move on. So for us to do what we need to do to solve for x, we're going to have to get that 3 to the x all by itself. So I got to move that 4. Okay? I'm going to move that 4 by subtracting 4 on both sides. Okay? So that's how I'm going to move that 4 is subtract it on both sides. So that's going to give me 3 to the x equals 16. And now we have it back to what it kind of looked like before, right? Just the original problems like 2 to the x equal 14. The same idea, 3 to the x equals 16. So in order to get x by itself, I got to introduce a log. Okay, so let's introduce the log to both sides. Log of 3 to the x equals to log of 16. Now that allows me to take my power down. Okay, remember this is basically the trick that you're going to want to do for every single one of these problems, whether they're considered advanced or basic. These are the basic problems right here. Okay, you want to get that power down. So we have x times log of 3 equals log of 16. And remember, all we're doing is dividing at the end just to get x by itself. So let's divide by log of 3. And you'll get your answer. So you go to your calculator, you're going to type in log of 16 divided by log of 3. So let's do that. Log of 16 divided by log of 3. And that's 2.524. So 2.524. You guys have any questions with introducing logs into the problems? Usually one question that I always get is, why do we have to do logs? I kind of told you that in the very beginning. The reason why we have to introduce logs is because even right here, if you look at this problem, there is no way for me to write 3 to the third equals 16, right? That's not true. 3 to the third is 27. 3 to the second is 9. So there is no 3 to the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. That is a 16, right? No actual integer type number that gives me a 16. So I have to kind of cheat my way through it, right? I got to try to trick the problem into doing it a different way. So by introducing logs, it allows me to get that power from the top, move it out to the front, and make it look normal, right? Just a variable on a normal equation instead of it being a power. Okay? So this is why we introduced the log. Not because it's just something we want to make more complicated. No, we're actually trying to simplify the problem by doing something that makes it possible for us to solve without having to use like a calculator and have that do it for us. So let's do some advanced problems, okay? Or what they would consider advanced. So we'll start off kind of small with the advanced ones. They might give you, let's say, like a 5 to the 2x equals to, we'll just put 20 here. So this kind of looks the same like the other ones, but notice the power of x is not just an x, it's a 2x. Okay? So they call these advanced. Okay? Because there's a little bit more you got to do at the very end. But not much. So again, I can't write 20 as a base 5. It's not 5 to the first, it's not 5 to the second, it's not 5 to the third. So I got to kind of trick the problem into doing what I wanted to do. So I'm going to use logs to rewrite my problem. So log of 5 to the 2x is equal to log of 20. Now because of that, I'm able to get the 2x and move it to the front, okay? So that's going to give me 2x times log of 5 equals to log of 20. Now, based on what I've already been doing, what is my next step? Well, I could divide by 2. What else could I do? Divide by log 5. Now, if we follow what I've been doing, I've always been dividing by the logs, right? But then you also said divide by 2. So why not divide by both? Right? So to get x by itself, let's divide by 2 log 5. Now, maybe you want to write 2 log 5. You can also write log of 25. That's up to you, but we'll leave it like that. Okay? So x is equal to, so let me type this in here, log of 20 divided by, I'm going to use another parenthesis here just to make sure it knows what I'm doing. Divided by 2 log 5, that's 0.931. So this was considered more advanced because the power was not just x, it was 2 times x. Let me show you one more problem that's considered more advanced here. So something like this would be considered advanced. So notice it's not just an x as a power, it's a 2x minus 4, so it's actually a linear function as your power. There is addition and subtraction that you're going to have to do to kind of try to get that 10 all by itself. Okay? So my first step here is to clear out the minus 3. So I'm going to add it. Okay? Just so we can get that minus 3 over to the right side. So that's going to be 10 to the 2x minus 4 equals to 28. Alright? Now, at this point, again, you're going to say, okay, 10 and 28, can I rewrite 28 as a base 10? Not possible, right? Because 10 to the first is 10, 10 to the second is 100. So No way I can write 28 as a base 10. So, okay, let's introduce logs then. So, log of 10 to the 2x minus 4 is equal to log of 28. That allows me to get that whole thing, 2x minus 4, and bring it to the front. Alright, so this becomes 2x minus 4 times log of 10 is equal to log of 28. Now, whenever you have an expression like we have right here, 2x minus 4, the way you do your work changes a little bit. Not this next step. This next step stays the same. But after that, we change some stuff just a little bit, okay? So, here we go. According to what I've been doing all this time, I should get rid of that log of 10 next, right? So let's get rid of the log of 10. So 2x minus 4 equals. Now what I would recommend here is actually solving for what it says on the right side. So I'm going to put log of 28 divided by log of 10 equals 1.447. And now just solve like you would a normal algebra 1 problem, right? So we got to solve for x. I have 2x minus 4. So what do I do first? Add 4. Good. So let's add 4. We got 2x equal to 5.447. What's my last step? Divide by 2. Thank you. So dividing by 2, x is, so 5.447 divided by 2 is 2.724. And there's your answer. So these are called the advanced equations, okay? Because it does require more work, okay? Your powers are not just x's, all right? So for the first assignment that you see in CUDA today, 7.8, it's going to be the easier ones. There's 10 of those, okay? And then 7.9 is the ones that have powers like these, a 2x minus 4 power, or maybe just a 2x power, but not just x. It's going to have something there. It might be an x minus 7 or a t minus 3 or something, whatever variable they're using. But you're still going to work on it the same way. You're going to introduce logs, bring down the powers, and just solve. Okay? So you guys do have 16 problems for homework today, 10 basic, 6 advanced. Okay? So I do recommend you try them out at least. And if you need a calculator, I'll bring them out for you guys right now.